Thank you everyone for the possibility to present here today. It's a great pleasure. And today I'm presenting work that's titled Climate Change and Fertility, Evidence from Spain. That is co-authored with Marco Cozzani, it's from the University of Bologna, and then Joshua Wilde, that's also based at the Max Planck Institute, as I am myself. So the research question that we try to tackle with this article is centered on how does extreme temperature affect fertility in Spain. And this paper is settled on this growing field of research that we talked about the past few days on climate change and demography, and it tries to contribute to fertility that, as been said before, has been less researched so far. And what we do here, we look at temperature as a form of exposure, and we look at fertility in the Spanish context. There has been already studies on this topic, and as presented before, for example, there are studies that did this for the US context. Then there is a study in South Korea, and then there is a study also in Sub-Saharan Africa, and then there is also a study in Hungary. And what all these studies showed is that there is a clear relationship between temperature and fertility, mostly between heat and fertility, and that this might be a concern considering global warming and how this might also further depress human fertility. So the mechanisms that have been so far kind of like advanced to explain these kind of associations are mostly three. The first one is related to sexual activity, even though in these regards a study in Hungary showed that there is not really like a relationship between temperature and sexual activity going on. Then there is a possible relationship between contraceptive effectiveness, so predicting that higher temperatures might actually have a positive effect on fertility because the contraceptive effectiveness of some medicaments might be lowering, but there is not much evidence for this. So what is kind of like left in terms of mechanism seems to be related to reproductive health, and this seems to be mostly related to men, as temperature might affect spermatogenesis, even though also this should be also looking at women health should be also interesting in this context. So here we focus on the context of Spain. That is particularly important in the European context because this country is strongly affected by climate change. That, for example, when we look at the temperature rate of mortality, this country is supposed to be the most affected in Europe. And it has quite low air conditioning coverage compared to, I don't know, South Korea or US, and even though it has quite a high economic development. So already now Spain has quite a low fertility rate, and this is shown to be also decreasing in the past few years. And then when we think about Spain being strongly affected by climate change and having already a low fertility rate, the projected temperatures might even more contribute to depress fertility. So here in this study we use data from the Spanish Statistical Institute, and that provides us with the total fertility rate at the monthly level for each province, and we have information on meteorological variables provided by the Copernicus database. And then our unit of analysis are those 48 provinces in Spain, continental Spain, and we observe them monthly from 2010 to 2018. And then our measure of temperature exposure are 7 temperature ranges that go from 0 to 30. And in our estimation strategy, we use a model that has been also, it's quite common in the literature and has been also talked about before, in which we try to account for seasonal trends or yearly variations in both temperature and fertility, introducing province by month and province by year fixed effects. And we also control for several factors that are, for example, solar radiation or air pollution, and also GDP per capita. And we weight our estimates by the number of women in reproductive age in the year prior. So to come to the results, in our main results we find something that's been also shown in the existing literature. So we show that cold doesn't really affect fertility with exposure to temperature 9 months, let's say, after, but we see a sort of linear decrease with an increase in temperature. So the effect size is higher with the temperatures above 30 degrees Celsius. And the effect size that we find is also comparatively larger to the existing literature, for example, South Korea or the US. And when we look at this, let's say, different months of exposure, we can observe, that there is a decline at the 9th and 10th month. And then what is also interesting, that's also been shown in previous research, is that we see a kind of a rebound in the months afterwards. So people kind of like recuperate the births that they lost during these months. And a similar pattern seems to occurs also with the higher temperature exposures in both cases. So we also wanted to explore heterogeneity in the effects, and we looked at the two characteristics that are age and socioeconomic status. And we focused at, for example, using mother educational attainment that is present in the data. We looked at mothers with no university education and those that have university education. And what we could observe is that we find a stronger effect size for mothers without university education, but that actually the coefficients are not statistically different. So we don't really observe a different effect by SES. Looking at mother's age, the pattern of no major differences is also observed. So based on these three different age groups, we don't see major differences in the effect size by mother's age of heat. And we also explored now a counterfactual analysis, so trying to answer the question of how much would have fertility in our sample have declined if temperatures were those expected in 2050 and 55 based on the shared socioeconomic pathway 245 scenario, so the mid-range scenario. And we also leveraged data based on this dataset that's by NASA, that's called the Global Daily Downscale Projections that give daily temperatures for the future. So what we kind of calculated using, in this case, a Poisson model, is that the reduction of births in our sample would have been of about 45,000 births, and the rebound would have been of about 26,000, so kind of like to a certain extent compensating for this lack of births, but a difference will be still of about 20,000 births. So in our full sample, we would have been experiencing about a decline of 0.4% if temperatures would have been those expected for the future. So coming to the limitation of this study, so as I've been saying at the beginning, mechanisms actually might be quite interesting to explore when it comes to this relationship, but in this case we could not specifically test them. And in our counterfactual analysis, we do not consider possible adaptation to heat that might occur in the future, as for example, air conditioning can still grow in Spain in terms of like how much people use it, and then maybe compensate for this larger effect size that we find in Spanish context compared to maybe the US. So, coming to the conclusion, what we show here is that exposure to both hot and very hot days in a context with low AC adoption but high income shows to have an effect on fertility. And when it comes to heterogeneity, we don't find differences by socioeconomic status and age. And this is what has been also shown in the paper for South Korea. And the possible reason for this is that people might not actually know how heat affects their fecundity. So they might not know that during summer it could have negative effects on their possibility to have a child. So both educational level and maybe age is not possibly a factor affecting or bringing up heterogeneous effects. And we also observed that there should be a larger decline based on expected climate change and also a post-moment of births, and this is what has been also shown, for example, for the Hungarian context. And in conclusion, we then can say that probably climate change with higher temperature might exacerbate even more the social problems related to low fertility and also affect the seasonality of births. And thanks a lot, and I look forward for your comments and suggestions.